Now that we've motivated multivariate regression with our example, I want to kind of stress and begin to discuss the exact nuances of what we're doing. And precisely what we're doing is if we are just adding one extra variable here, so we're only talking about two covariates and our outcome, you can see how, and please remember how we're drawing the best linear line through our x1 and our y. Well, now essentially what we're doing is we're just adding an extra dimension and still drawing the best line through that multi three-dimensional space here. So we're still trying to minimize the sum of squared deviances just between this estimated regression line and the observed values in each of our covariates. So inherently, when we add in another variable, that's going to change how we're drawing our best fit line through this multi-dimensional space. And I want to discuss that in a little bit more detail. So again, think about our example that we're using where we first started with just our main covariate of interest, the second quarter to GDP growth, and we ran our first estimated regression model. We can see that with a 1% increase in GDP growth in quarter two, we would anticipate that the incumbent party vote share would increase by about 0.75. Now, there's two things that I want you to think about when you're looking at this regression output. One, just in general, what do the coefficients and the standard errors mean? And I'll pause for a second for you to think about this. Now, again, I'll reiterate with words, and this is how you should describe it in your problem sets when you're asked to describe what the relationship is between the covariate and the outcome and interpret the coefficient. So here in model 2, we can see that when quarter 2 growth increases by 1, then we have an estimated increase of 0.5 in the incumbent party's vote share. The second thing that I want you to think about is why did that value change between model 1 and model 2? In other words, why are we decreasing the amount that the incumbent party vote share or the predicted amount should increase for just a 1 unit change in our second quarter GDP growth? And I'll touch on this in a second, but again, what's likely happening is that people's approval ratings are probably driven by the economy, right? And so June would be essentially what would be happening in quarter 2. So these are essentially co-varying with each other. So again, what we talked about in problem set 1, and what I tried to start to force you to think about when I made you plot not only the relationship between the covariates and the outcome, but the covariates themselves, is because we need to start thinking about the data in this multi-dimensional space in which the covariates are varying with each other. They are impacting the direct effect of each of them, right? Because we're shifting this hyper plane in multiple dimensions. So again, we're trying to estimate something that looks more like this, where we have two variables, our second quarter GDP growth and June approval. And again, we have observed values for both of those covariates. We also have observed values for vote share. And what we're trying to do is create a line that goes through both of these dimensions and minimizes the squared error between what we observe and that estimated linear hyperplane.